Hello again, students. Oh, this is starting to feel more weird by the video. I feel like I should be waiting for Nettie to get here on time, or somebody to look up from their computer, or Hayden to notice that I'm in the room with you guys. It's a weird feeling, but we'll get rolling. We've got 2 units left here, and this is our last 2 units have to deal with probability. And so we will start here with this first unit is a lot of the probability rules. Some will be familiar probably from your higher algebra days. And then our last unit will be random variables, which is some new material that will probably be a little less familiar, but again, some areas or some things you have seen in the past. So probability rules. This is, I think there'll be about 4 lessons that I'll make for this unit, and here's the first. So a couple things you're going to want to take away here is what does probability mean, and really how is it determined in the beginning? So not just some of the ways you've applied it, but what does it mean? Then we'll have some rules that we talk about, and then we'll talk about independent, disjoint, and complements. So first of all, probability by definition. As you can see here, proportion of times the outcome would occur in a very large series of repetitions. And what this means is we just talk often about, the probability that you roll a 6 on a die is 1/6. Well, where that was established in the beginning was rolling a die a bunch of times to make sure it was 1/6. At that time, we didn't have things that could measure the weight in a die to make sure it was fair, and so you just had to roll it, or you had to flip a coin to make sure that the coin would be 50-50. And you couldn't just do that 10 times. You had to flip the coin 1,000 times to make sure it was going to end up close to 500 to 500 in terms of heads and tails. So probability is a large series of repetitions where it's established. And now, of course, we have the ability to think about it more theoretically, certain situations, but it really started that way. Probability rules should be largely familiar here. So this first one just means that probabilities can only be 0 to 1 inclusive. Rarely do we see a 0% probability or 100% probability, but they can only be from 0 to 100%. Again, this is debunking the whole professional athlete. I give 110%, can't happen. 100% is maximum, of course, and so we want to stay between 0 and 1 there, kind of like p-values. A lot of times I talk about students would get 2.5 e to the -4th for a p-value, and they'll just write 2.5. Well, that means 250%. That's impossible. So if you see a number that looks to be over 1, there's some sort of to the negative something that you'll see if you keep going down the line on your calculator or whatever it may be. This here, rule 2, probability that S equals 1, that just means the entire sample space equals 1. So if you think about like up here up top now, when we roll a fair die, we know that it's going to be a 1, 2, 3, or a 4, 5, or 6, which means for the whole sample space, the whole thing has a total probability of 100%, that it's going to be, in the end, 100 out of 100 rolls will be one of those 6 values. And so the whole sample space is 1, just like heads, tails. Okay, you have heads, tails. They aren't always going to be equal. It could be something like the Powerball, where here's your win percentage way up here, and then the rest of this is your lose percentage. But that's, again, the whole probability is 100% of everything happening. Complement rule. Complement is like a heads and tails thing, where it's either this or it's everything else. And so complements could be like here, that you have the heads versus the tails. 1 minus the probability of heads gives you tails. Or it could be something up here like with the dice, where we have you could get a 1 or you could get everything else. So there's a 1/6 chance that you get a 1, and then 1 minus that means there's a 5/6 chance that you'd get anything else, which of course would be the 2, 3, 4, 5, 6. So complement just really means, doesn't mean they have to be equal, but it means there's this, and then there's everything else. This is a complement right here. That's what this superscript C stands for, is complement. Addition rule. Addition rule just means if you have disjoint events, meaning there's no overlap between the two, that the probability of one or the other happening is just the sum. So that would be like the probability of rolling a 1 or a 2 would just be the probability of rolling a 1 plus the probability of rolling a 2. Probability if you select a card from a deck of cards that it's A heart or a diamond would be the 13 out of 52 probability that's a heart, plus the 13 out of 52 probability that's a diamond, which of course is 26 out of 52, or 1/2, since red cards make up half the deck. Now, not all events are disjoint, so you do have to be careful with that. And so you just have to be mindful, but if they're disjoint, then you just add them up. Sorry for any residual noise here. The 5-year-old's down looking for hockey figurines. Um, Oh, he found them, so he's happy. Rule 5, multiplication rule. Multiplication rule is, oh, and almost fell. Oh, and he has officially fallen for the 923rd straight day. Um, Rule 5, multiplication rule. Independent events, we'll get we'll get into independent events a little more. Update, he slipped over on a ball, he said. Um, Multiplication rule. So the independent events we'll talk about more, but the probability of having both occur is just the product of their own probabilities. So that's something we will expand upon later, and so we won't get into it much now. Here's just a representation of disjoint versus complement. This is disjoint here, where it just means there could be other things that could happen, which is the black space, but every individual event that we're tracking has its own probability and there's no overlap. Okay, so this would be like, I know it's not equal in terms of space, but it would be like rolling a 1, a 2, a 3, a 4, a 5, and everything else would be the 6. Okay, so there's disjoint just means no overlap. Complement here just means it's one or the other. Okay, so they could be 50-50, it could be 5-95, it could be 90-10, doesn't matter. It's just that it's this one or the other one. A lot of times it's easiest to use complement where you have to find the probability of it being one of 9 out of 10 things. Instead of adding up the 9, you just subtract the 10th from 1. And then you get the other 9. So that's a good time for complements. Okay. Independence. Independence is the biggest thing in this unit. And independence simply means this here, that whether when one event occurs, the probability of any ensuing event doesn't change. And so a big one with this would be like you take a card out of a deck of cards, and you select this card, and it's the ace of spades, and then you put it back, and then you mix them up. And so when you put it back, the chances of selecting any card, of course, goes back to 1 out of 52. If we didn't put it back, which is called without replacement, then the probabilities would change, right? It'd be 1 out of 51 for the rest of them, and you'd have 0 chance of selecting the ace of spades again since it's already out of the deck. That would not be independent. So independent is really where any previous event does not affect the next. Flipping a coin, of course, is independent. Rolling a die is independent where there's no memory. But independence plays a big role in this unit, and we'll talk a lot about independence, like the idea of, a common one is what political affiliation you have. Does that change depending on your gender or your ethnicity? And if it does, then that means that your gender is not independent of your political preference. But if 40% of Americans are Republican and 45% are Republican and 45% are Democrat, and it's the same given whether you're male or female. If 45% of males are Republican and 45 Democrat, and if 45% of females are Democrat and Republican, that would be a situation where it's independent because it didn't matter what gender you were. Of course, in reality, we probably would say that your gender does influence your political preference, and so those would not be independent. Independence versus disjoint. These two can get mixed up often, and what the difference here is, disjoint really refers to the single trial. Okay, so that's like one time rolling a die. You can't get a 1 and a 2. Okay, so on a single trial, events are disjoint when there's no overlap, versus independence talks about successive trials. That idea of one try doesn't affect the next. And so just understanding that distinction between disjoint and independent is important. And finally, this one is a unique one. What is the probability an AIDS test gives at least one false positive amongst 140 employees if the probability that a test is a false positive for a single person is 0.005 or 0.5%? So of course, when we say at least one false positive, what we're really saying is that X is greater than or equal to 1. This is a capital X, by the way, just for grammatical purposes. So you'd have to find the probability of 1 false positive plus the probability of 2 false positives plus the probability of 3, all the way up to 140. Okay, So rather than do that, let's just do 1 minus the probability that there are 0 false positives. Okay, so key here is this word at least. A lot of times when you see that word at least, that's going to mean 1 minus, because it's a lot of times when you see at least, it's saying at least, it could be saying at least 5 out of 500, in which case you could either find the probability of 5, 6, 7, 8, 9, 10 all the way up to 500, or you could find the probability of less than 5 and just do 1 minus that. So we're going to do 1 minus the chance that there's 0 false positives. So that would mean that every single one of these is correct. Well, the chance that every single one of these is correct, okay, the correct probability is 1 minus 0.005, and we would be saying that there's 140 correct, okay? Now, or what we could do is there's 0 incorrect, and then 140 correct. And so that, I skipped a step there, but that anything to the 0 is just 1. So it's really just 1 minus the probability that every one of these is correct. So it's a lot of logic in thinking, okay, what does 0 false positives mean? That means that if none of these people have AIDS, that there would be that 99.5% chance that it would recognize that, and so that would happen 140 times over. So the interesting thing about this is when you take 0.995 to the 140th, this is actually 0.4957. So that means in a group of employees, that we have 140 employees, and we have a test that's 99.5% accurate, that would mean there's over a 50% chance that somebody would be told that they have AIDS when they actually do not, even though the test is that accurate. And so it's a bit alarming. But again, what this is showing is a couple of things. Complement rule, which is the 1 minus, and independence is the idea that one person's test does not include or does not affect another person's test. So we should recognize here that these tests are independent of each other, which of course I did not put in the question up to this point. So we're seeing that here. This is just a calculation, one example of these in action. Again, a bit alarming, the idea of false positives, but that's what we're seeing here. We'll get into a lot more examples here in the future lessons. Thank you. I'll see you in a bit.